Thank you very much. No problem at all. All right, so thank you for coming to this presentation. My name is Michal Micro-Převrátil. I'm the head of tooling at Eki Blockchain, and we are smart contract auditors, and so we have a pleasure to work with many exciting projects, like, for example, Aave, Lido, or Safe. We've also received several grants from Ethereum Foundation, Coinbase, Optimism, and actually the last ones from Coinbase and Optimism allowed us to extend the capabilities of Wake and add some new interesting features. As I said, we are smart contract auditors, but we also love open source and building open source, and Wake is one example of that. Another one is Trident, which is a leading tool for Solana fuzzing. And except for open source, we are also onboarding new developers to the ecosystem, for example, through courses on the Czech Technical University here in Prague. All right, but let's start with Wake. So what's really Wake? Wake is a framework for testing. So it allows to write a simple unit test, just testing a single use case, or, for example, to do integration testing through forking. So basically, it's possible to fork any chain existing into local testing environment and just use all the contracts from the external chain, from the fork chain in your local testing environment, and test all the integration with your contracts you are developing. And finally, it's also a framework for fuzzing. I will get to fuzzing later on, so I will skip it for now, but it's a special testing technique. It's also a static analysis framework, and so it allows to detect some common issues or vulnerabilities in your code through detectors. There are also printers that are somehow the same as detectors, except that they don't detect some issues, but they just print some interesting information about the code in your code base. And finally, it's also a language server, which is kind of harder to explain, but what it means basically, there's an extension, it's called Solidity Wake, which is powered by Wake, and it basically gives the users all the nice features like code highlighting, go-to definition, it shows the references of variables above each variable, and so on. There's a lot of features. I will also speak about it later on, so I'm going to skip it for now. All right. Let's move on, hopefully. Yeah, so let's compare Wake to other solutions out there. There's quite a lot of tools in this image, and I will try to very briefly describe like the differences and the tools, what they are about, and so on. So first of all, we've got Slither here, and well, it's mainly a static analysis tool, so it only has detectors for finding some common issues in the code base. It's still maintained, it's written in Python, and well, yeah, that's basically the only use case to find some interesting detections. Then there's also Ape, a framework in Python again, which is maintained, and well, it's mainly for testing. We've also got Brownie here, which unfortunately is no longer maintained, but it was used, or it can be still used for testing. It also has support for fuzzing, but only through Hypothesis plugin, like an external plugin, and it's not built into the framework directly. There's also Hardhat, which is not in Python, but in TypeScript. It's still maintained, used for testing, and it also has its own language server and also an extension. Then, of course, there's Foundry, written in Rust, mainly for testing, fuzzing, and as far as I believe, there's also support for detectors being added, but as of today, there are no detectors to be run. And finally, there's Wake, it's written in Python. It's got all of the features combined together, still very, very powerful. But, well, this table is actually outdated because I am pretty excited to announce today that we have finally open sourced a new testing part, a new testing core for Wake, which is written in Rust. And I will speak about it later on. But basically, Wake is no longer just a Python tool, but a hybrid tool with Python and Rust combined together to bring new features to the framework while keeping the old ones, keeping the same syntax, the same use cases, and so on, but with higher speed. So yeah, let's move on. Wake helps us to find many interesting issues. There's a sample of findings we have found thanks to Wake in many interesting projects. And some of them were found with a single unit test, some of them were found with fuzzing, and some also with static analysis with detectors. And I believe actually a few of them also were found with both static and even dynamic analysis. So one could choose the preferred method. All right, so let's now focus on deployment and testing. I've got a very simple example here of a deployment script. So this is how a very simple deployment script may look like in Wake. First of all, we import from wake.deployment, import all the necessary stuff we may need to use. Then there's something called PyTypes, and it's basically typing stubs for contracts in your code base, but exported to Python. So each time you are interacting with your contracts in Python, you have the typing stubs, so you have the auto-completions and also typing support, and let's say there's a function that in Solidity accepts a string. You pass an integer by mistake in Python. It's all highlighted because there's typing support, and it's also easy to fix it and use auto-completions to write the code easier. And it actually also helps AI agents to fill in the code because they know Python and they can look into the PyTypes, and so it's also easier or more efficient to write scripts like these. Let's continue with the code snippet. So there's some connection to a node. We are assuming we are running a local node. And also with Wake 5.0, which is coming in the next weeks, there will be added support for Trezor. So it will be possible to deploy contracts using a Trezor account. And once we have the account, we can just deploy the contracts and set some parameters, and it will send a transaction. And once the transaction is mined, we can print the address of the token and, for example, also print balance of the account we've used for the deployment. Now let's compare the deployment script to the testing script. And as you can see, it's almost the same. And it was intended to make it the same for deployment and for testing. So it's one single user interface or like API, but only because of different import, we may have either a deployment script or a testing script. And otherwise, I think it's quite the same, except in the testing script, there's a mint ERC20 function, which is like a cheat code that allows us to mint ERC20 tokens for anyone, for any ERC20 token, and it's only possible because of the testing environment. All right, so, sorry, I skipped one slide. Yeah, so this is what helps with debugging in Wake quite a lot. This is a call trace of a transaction, and as you can see, there are all the subcalls with the parameters inside the transaction, and this helps quite a lot to debug some complicated stuff when testing, or maybe even when doing a deployment of a contract. So this is something that's offered by Wake. Then there's the animation. So we are running a test in Wake. We are running a fast test with some debugging option. And once we encounter an issue, an assertion error, we can enter the debugger. We can print the code around the issue or the line where the issue occurred. And we can print also a call trace for any transaction that happened in the past. And we can print the local state and even some, let's say, global state saved in Python, or we can interact with the contracts on chain. We can even send new transactions, deploy new contracts from within the debugger. So it's very powerful, and it helps a lot when, again, debugging some complicated stuff. All right, so let's talk about the performance now. You may think, or it's quite well known that Python is not very fast in general. Yeah, let's admit that. So we've taken a Uniswap v3 repository, which already contains a lot of unit tests, and we've migrated 271 unit tests. which were originally written in hardhat, so in TypeScript. And we have re-implemented those tests in Ape, Brownie, and Wake. We've also used like different testing backends, or how we want to call it, basically development chains, which are Anvil, Hardhat, and Ganache. Ganache is unfortunately discontinued, but we still kept it for the reference. And we've ran all the 271 tests, and these are the results, how long it took to run all the tests. And as you can see, it's not only Python, but it's how you use Python. So Wake was quite fast, especially with Anvil. It also shows that Hardhat was quite optimized for Hardhat node, obviously, but well, Python still can be quite fast. But that isn't enough, in my opinion, because well, there's Hardhat missing. Sorry, no Hardhat, but Foundry missing, for example. So we've performed another benchmark, but before I get to the benchmark, I want to introduce fuzzing finally. But first, maybe one question. How many of you have ever heard about fuzzing? Please raise your hand. Good, that's very good. Okay, thank you. So just a brief introduction to fuzzing. It's basically about creating random sequences of functions being called, or let's say random sequences of transactions, also using random inputs, random data inside of transactions for the function calls. And so since we are dealing with random data, it's very important to have the execution speed as high as possible. So with the higher execution speed, we can test as many test cases as possible because it's random data. So the more test cases we are testing, the higher the probability we will find an interesting issue. And I've got here an example of a very simple unit test where we are basically transferring 1,000 tokens from Alice to Bob. And there's also assertion that Bob actually received those tokens. This is a simple unit test. And if I had to rewrite it into a fast test, then it would look like this. And what's the difference here? We have a sender, which is a random account, also the recipient for the tokens, which is again a random account. And there's also the amount, which is a random integer in between, let's say, 0 and 10,000. And otherwise, it's quite the same, except we don't set specific numbers and parameters. Instead, we use just random data. And what's the difference here? It's quite significant in this case because of the random data, we may actually have a collision in between the sender and the recipient, and so we can test how will the contract behave if we send some tokens from account to the same account, how it will behave. Will it revert or will it continue? Well, it depends. It depends on the implementation. But this was naturally tested because of fuzzing. And in the unit test, we would need to write a very specific unit test just for this case. Also, what's being tested in the fast test, in the fast test flow, is what if we try to transfer 0 tokens? Because there's also 0 in that amount that may be generated. But it's not being tested in the unit test because it's a unit test and there's 1,000. But in fuzzing, there's a range in between 0 and 10,000, and so we may also generate 0 and so test how it will behave when transferring 0 amount of tokens. And finally, I can show you the second benchmark we've performed, which mainly focuses on fuzzing, hopefully. Yeah, so let's compare some well-known fuzzers. And we didn't implement our own fuzzing benchmark, but instead we've taken Daedalus benchmark, which is originally implemented, I believe, by consensus. And well, basically it's 5 mazes, which you can imagine as a grid of 7 times 7. And for each maze, which means for each grid, we've run a test or a fast test for 20 minutes on one CPU, on one processor core, and we've compared the results. And I hope I can show you how a maze looks like. Also, what's important, and I will wait for the image. Yeah, so this is the maze. As I said, it's 7 times 7, and always we are at one at one cell in the maze, and we can move in 4 directions. We can move up, we can move down, we can move left, we can move right. And each time we are moving, we also need to set 8 uint64 parameters. And depending on these parameters, we may either find a bug or not. So finding a bug depends not only on the location inside the grid, but also on the parameters that we are passing when moving to a specific cell. So yeah, there are also walls sometimes, and we cannot walk over the walls, obviously. So this is how a function that moves us to a different cell looks like. As I said, there's 8 uint64 parameters. And what this benchmark is all about, we need to find, or we want to find, as many bugs as possible within those 20 minutes on one computer core. All right. This is an example how a bug in the benchmark looks like. So the first if is about the location, about x, y coordinates inside the grid. And the rest of the if conditions is for the parameters we are always passing when moving in a certain direction. Some of those conditions are quite easy to accomplish, to satisfy. Let's say, for example, P4 is less or equal than P6, but some are quite, well, uneasy to satisfy. For example, P3 must be less or equal than P3 and multiplied by P0. This doesn't give us a lot of space. Basically, we need to supply 0 or 1 in this case. I can also say that this specific bug was detected by Wake. We were able to detect this one within the 20 minutes. And let's finally see the results. So as I said, there's 5 different mazes, and we have the most popular fuzzing frameworks for Solidity smart contracts here. So there's Echidna, there's also Foundry, there's original Wake just in Python, but with the Anvil as the backend for EVM execution. And as I said, we have open sourced a new addition to Wake. It's a testing core, testing framework written in Rust, and we call it Wake RS. And so you can also see the differences. Otherwise, what's also important to say, the numbers here are how many issues we have found within those 20 minutes. And yeah, so as you can see, it depends on how you use Python. And if you use, let's say, something more powerful for execution in the background, and well, what made the difference here is just the execution speed. Otherwise, as you compare Wake plus Anvil and Wake RS, they use the completely same algorithm for generating random numbers, and the only difference was the execution speed. I've also added here how fast we were able to submit or send transactions. So with Wake plus Anvil, we've achieved around 145 transactions per second, while with Wake RS, which means Wake plus the Rust execution engine, we've achieved almost 9,000 transactions per second. That's almost 60x speed up. That's quite a lot. And as you can even see on the results, it helped us to basically make Wake RS or Wake plus the Rust part the most efficient framework for fuzzing in terms of black box fuzzing and also of this benchmark. All right, and finally, let's talk also about the extension and the language server. As I said, we have our own VS Code extension that's called Solidity Wake. And yeah, this is the extension, how it looks like on the marketplace. If you want, you can scan the QR code, and it's just the extension for VS Code. There's many features like, well, code highlighting, go-to definition. There's number of references for each variable and control flow graphs, inheritance graph, and so on. I will also show you some of the interesting features later on. So I will let you to scan the QR code. And yeah, I think we can continue. So this is an example. As I said, Wake is also a static analysis framework, and so it can detect some issues in the code base. There's an example of reentrancy, and obviously there's a command line interface to run all the detectors and see some results. But we have also integration into VS Code with the extension, and so we can show the detections right inside the code. As typing the code, new detections may appear. So this is an example of reentrancy. So there's possibly a reentrant external call, and this is how the detection looks like inside VS Code. As I said, there's also some interesting graphs that can be exported. So there's an example of inheritance graph, and basically when there's the contract, interchain token, then some inheritance, and there's always a label above the contract name, and when clicking on the label, we can basically see this exact graph inside VS Code. It's rendered, it's shown inside VS Code, and also all the nodes, all the base contracts in the graph are clickable, so it's possible to click on them and open to the contract itself, like the code of the contract itself. And finally, this is the newest addition to the extension. We call it Deploy and Interact UI. And well, it's kind of Remix-like feel, but inside VS Code. So we can compile all the contracts within the code base. Then we can see a list of those contracts in a list. We can deploy any of the contracts. And once we have the contract deployed, we can send any transactions or just calls to interact with the contract. And once we send a transaction, we can also see the call traces for the transaction. We can see the events and so on, basically any parameter of the transaction. And yeah, so this is how the UI looks like. We tried to make it as easy to use as possible. And there's also support for forking. So within this UI, it's possible to fork any chain, any existing chain, for example, the Ethereum mainnet. And when forking, it's possible to add existing contracts to this UI. So we can just simply copy the address of any contract, insert it into the UI, like you see on the screen. And then, because if the contract has the source code public, so we can fetch the ABI either from Etherscan or from Sourceify, we can see all the functions that are available for the given contract, and we can interact with the contract as if we deployed it ourselves, except it's been forked, and we don't even need the source code in our local project. And yeah, I think that's all from my side. This is a QR code leading to the landing page of Wake. So if you are interested in Wake, in fuzzing, in static analysis, or even about the extension, this is the main landing page. And there's also a link to GitHub, to the documentation, and so on. There's also a list of issues that were found thanks to Wake. So be sure to scan the QR code. Eat Wake is the name of the Python package, and we have also a Telegram group where you can connect, ask any questions, and we are trying to help newcomers to Wake, to the Wake framework.
Okay. Thanks a lot.
So yeah, I think that's all from my side. Thank you.